This
Kubernetes.
conference will now be recorded.
Correct. So see, Docker you have learned right now, and containers you have learned. Let's say it's a very simple way I'm putting up. Let's say you want to run your production on the VMs. You want to run the production. Where do you go? So you go to AWS, you go to Azure, you go to Google Cloud. Probably you have your own data centers, like, you know, that way, correct? So if you want to run VM at the production scales, you opt for the cloud services. Why? Because you get lots of resources. Which are the resources? Compute means VM, simple way, right? Then you get storage, you get networking, you get security, right? You get DNS services, load balancers. So many things you get at one place. So for that reason, you go to AWS. Simple reason, correct? Correct, right?
Yep.
Now, you all love containers. So from the VMs to we are migrating to containers. So containers basically is like, you if you want to run in your laptop, you can install the Docker and run it, no problem. But what about I want to run thousands and thousands of containers? Think about it. Not one and two, thousands of containers I want to run. So I can't run every thousands of containers in one VM. I have to run in a multiple VM. So I need somewhere the capabilities where container orchestrator we need. Okay, container orchestrator. That means we need some tool sort of it which can manage the, let's say, 100 host, and each host you have 110 containers like that. So we need such kind of management. AWS will not do that for you. AWS will not do that. Azure will not do that. So we need a container orchestrator capability where we can run the containers at the large scale, and that tool should manage. Okay. That also, when you run container in the large number of machines, networking challenges will be there. That tool should solve it. Storage challenges will be there. Security issues, DNS, load balancer. So all these things, what you were looking for AWS, VMs and AWS, now we are looking for the containers. Same solutions. We need now we need containers is your compute. We need storage for containers. We need networking for containers. We need security for containers. You need a DNS for containers. You need LBS for, load balancer for containers. So how do we do that? The answer is Kubernetes. Okay. Answer is Kubernetes. Kubernetes will help you to orchestrate the container. We call it orchestration. Compute orchestration, storage orchestration, networking orchestration, security orchestration, DNS orchestration, load balancer, and many more actually. That means if you want to run in a simple way, if you want to run container at the large scale, you have so many challenges. That challenges will be solved by Kubernetes. Are you understanding? All of you?
Yes, sir.
Yes, sir.
Okay. So in a simple way, if you say Kubernetes is for the running the container at the production level. You can run in the pre-production also, but primarily it's used for the large containers and stuff like that. Okay, so now this tool is written in Go. Okay, now this is from the CNCF. CNCF is a product, is a foundation which govern multiple products. So you should spend some time on their website also. Okay, cloud native for computing foundations. So many of the projects I'm teaching you as part of this training. So if you go to this here, Prometheus, Kubernetes, and many other products also I'll be covering. Here it's a Kubernetes. Here is a Prometheus, right? So yeah, this is something which we have. Now this is open source, okay? And this is something like I have discussed for orchestration for containers. Remember that, for containers, everything. All the networking challenges will be solved by Kubernetes and all many things. So now the question is how Kubernetes works. How Kubernetes works. This we need to understand very clearly. Okay, so this we need to understand very clearly how Kubernetes works. So basically what happens, there are three set of machines we have. I call it workstation. Then there is one machine we have a master. Multiple masters can be set up, and there is a worker. Multiple workers can be set up. Okay, so this is the, you can say, architecture or something like that. So here you have you you send a request to control plane. Now what is control plane? This is the master. Typically we call it control plane. I'll tell you a little bit later. And then containers are running here. Pod. What is a pod? I'll discuss about it in some time. But containers are running here. Okay. So this is the overall architecture. So out of which these two things together, we call it cluster, Kubernetes cluster. Okay. So clusters, we have a master VM and worker VM. Okay, this can be VM, it can be physical servers also. This can be VMs, it can be physical servers also. But
Okay.
most of the time nowadays we have a VMs only. Master VMs, worker VMs. Master VMs which manage the entire cluster, worker VMs which runs your container in a form of pod. This is your laptop workstation. This is where you are there. Okay, so at the high level so far so clear, all of you?
Yeah.
Okay, so now in your workstation, what you will install? So you will have a kubectl. There's one utility executables. I'll show you, don't worry about that. Executables. Now here, how can you make it a master? So primarily you need a minimum four software. It can be few more also. Minimum four software, four applications. You need it. Which are those? So you need, one is API server. This is the most important component. kubectl. All the external communications, if you want to send some request to the Kubernetes cluster, I'm saying Kubernetes cluster, any request you send to API server. This is your gate, main gate. Every communications you send, any request human sends, send to API server, and then this stored in the etcd. This is your, what is this? Etcd also CNC product. If you see that here, etcd somewhere, it should be here. Here it is. So what is this etcd? It's a database. Persistent storage we call it. That means anything which you send a request, API, it's stored in the API server. API server stored in the etcd. It's a key and value form of database. It's like a MongoDB, key and value format like that. So it's a database. But we have a few more components also. We have a controller manager. As name suggests, just divide, understand the name actually. API server. That means here you have hundreds of APIs, means hundred of functionality of Kubernetes. Controller manager. This is the manager component. So it has a controller, multiple controller, tens of controller. What controllers are doing? This monitor your clusters for status reporting and all. And there's one more, scheduler. Just understand the meaning, actually name of meaning, scheduler. This schedule the work to the worker. Schedule the work, scheduling the work. Okay, so these all four components, they talk to each other. This is the minimum uh, resources they have, and this four software is installed it, then it's become a master. Okay, now this visualization is not good. Let me show you. I don't want to use my slides because it will become a very long session. So just I want to show you the components of Kubernetes master machine. Okay, and look at this. I think this image is okay for time being. See here, you have a API server, you see, etcd, scheduler, controller manager. This whole things is in a master VM. Clear, all of you? Hello?
Yes, sir.
Sir, sorry,
Okay.
as I'm mute.
So now these are the four things. Now few tools are also there. Which are the tools? These are the application software. Okay. So few tools are there. For example, kubectl. You have kubelet. You have kuberium. Am I missing Docker? You know that. Containerd. CNI and stuff like that. So these are the tools are there. Tool means executables. Okay. So kubectl, kubelet, kuberium, Docker, containerd, CNI. Okay, there's one more component I would like to mention here, which you have kube proxy. This is also application. Okay, so in offline, after that, probably you want to research each and every component in detail, but for only for knowledge purpose. Uh, if you have a good knowledge, then it's good. So kube proxy is networking services. Okay, so and these other tools need to be installed in every masters. So what is this? kubectl is a client. Client talk to API server. Okay, now kubelet is an agent for each machines, each node. That means this kubelet will be there in the, see, by the way, these all utility will be there in the masters also, and then worker also. Every nodes you will have it. Mind it, this is the common utility. I'll write it common for worker and masters. This will be common utility stored. Kuberium is for the administrator. Let's say you want to set up a master, you want to set up this whole component, right? Then you run kuberium init. You want to set up worker component, worker, you want to run this in a worker, so kuberium join command. Okay, I'll show you that. So when you want to initialize this all four components, it will be done automatically when you run the kuberium init. When you run kuberium join, worker will be set up. Docker, you know that it's for the containers. We have spent some time. So containers, and this is also for the containers, containerd. Kubernetes supports containerd. Okay, Docker we need for the images and all, and CNI is for the networking, container networking. So these are the, this is also for the container networking. Okay, please understand that. So this is a, you can say, uh, um, you can say, um, driver. Sorry, this, you can say, this is a device and this is a driver software, because everything is virtual, right? So like that. So this is for the container networking. Okay, so now you understood All these components will be there. These are the executables will be there, and these are the softwares will be there. Okay. Now don't worry about that. Just for understanding purpose, you need to know, because I told you, right? The moment you do the Kubedium init, this whole software will be set up on certificate access. Everything will be set up automatically. Nowadays, a lot of automation cloud has done it, so you don't have to interact. In fact, but in order to build a better understanding, you need to know actually. Now in the worker, what we have, so these are the common tools anyways you have, and you will have a proxy in the worker. Okay, here minimum one app proxy. Okay, so this is the architecture of Kubernetes clusters. So these are the components of the Kubernetes clusters in simple way. Okay, so if I'll give you in simple way, if anyone asks, hey, explain the architecture, so you say, hey, we have a clusters. Okay, Patrick, you're hearing me, right? All of you?
Yes.
Yes, yeah.
Yeah, so it's for the interview purpose. I'm telling you, if someone asks you, hey, how Kubernetes works, tell me, explain the architecture of Kubernetes cluster. So a Kubernetes. So you will say, hey, we have a Kubernetes clusters, and Kubernetes clusters is divided into the two types of node: masters node and worker nodes. Master nodes, we call it sometimes control plane also, and worker nodes were the typically that we run our application, containers applications, pod. Okay, I'll discuss about the pod a little bit later. Now, how can we set up a master? How master node can become a master? Or how, which are the software required to make a master, behaving more like a master? So these are the four software minimum required. Okay, which are those? API server, controller manager, scheduler, and proxy. How this we get this software? We run Kubedium init and we get it. Simple. Okay, this software is initialized by Kubedium init command. Okay, what are the softwares we have in the worker? So we have a proxy, proxy. Okay, how do we get this proxy in initialize in the worker? The moment we run kubedium join command, we initialize the worker machine. Okay, and this they will say, hey, how this communication authentications is taking place. So between the master, worker, and workstation, certificate is being used. Remember, communication authentication, for authentication, certificate is being used. So when you set up a cluster, automatically it get created using certificate. Never forget. Okay, certificate. There's no password as such. Okay, certificate. This authentication means certificate between the you to control plane to the worker. I mean master to worker. Everywhere certificates. It's automatically has been configured. Okay, there are some port specification also. Right now you don't need to know for that. Okay, so that is thing. Next thing they'll ask, okay, which are the utility you will have? So you can say in the every VM, master VM and worker VM, kubectl need to be there, kubelet need to be there, kubedium need to be there, docker need to be there, container D need to be there, CNI need to be there. These are the common utility, common tool set required in the nodes, master nodes and worker node. So kubectl, what it will do? So kubectl basically connect to the API server. Let me tell you here, you are the here, this is your laptop, you need a kubectl. Why? Because you want to send a communication to API server. But here in cluster also there are so many components, right? They also want to talk to API server. See here, look at this image, visualize this. For everything, this image is not coming well because API server is not depicted properly. But if you see this image, look at this. For everything there is API server. Look at this. See, scheduler, controller manager, everything is talking to the API server. Correct, no? Now, if you see proxy, kubelet also talking to the API server. This is a worker node. Are you understanding? Yeah. So kubectl needed everywhere. Now, what is a kubedium? Kubedium is administrator tool. Using this, you can create a master, you can create a worker, you can create a certificate, a token, and many more work. You can clean the master, you can clean the worker, many things you can do that. Docker for containers, container D for containers, CNI for the container networking. So you have to explain in this way. And again, you have to little bit practice each and every components. I would suggest write a blog for it, understand how it works, and so on. Clear, all of you?
Yes.
Okay, so now you understood what is Kubernetes and why we need it. and then how it works. Now, next question is, do we have any replacement for Kubernetes? Answer is no, not even one replacement. Okay, so there's no alternative for. There was an alternative, but it didn't work out. Swarm, Docker Swarm, but didn't work out. So that means forget about that. Looking for the best tool in the container orchestration category. There's no other tools except the Kubernetes. Is a market leader and dominating 100% of market. Okay, so now question is, how can we install Kubernetes? Set up this Kubernetes clusters basically. How can we set up Kubernetes cluster? So guys, more than 40 methods are available to set up a Kubernetes cluster. You can set up in your laptop also. You can set up in AWS also. You can set up in Google Cloud also. You can Azure also, VMware also, VirtualBox also. I mean, literally, you can set up a lot of ways. Everyone supports Kubernetes cluster configuration, and the instructions will be different. Ubuntu has a different instruction, CentOS has different, and all stuff like that. So don't get lost in those. You need a Kubernetes clusters. That's all. Okay, so how do we set up? So now I am going to show you the demo using the traditional way, which typically Kubernetes follow, manual traditional way. But most of the time in your environment, when you use Kubernetes, you'll be, let's say you are on AWS, so they will use EKS. Okay, if you're on AWS, you have EKS. If you're on Azure, then AKS, and then if you're in Google Cloud, GKE. These are the popular ones. Say, okay. So AKS means Azure Kubernetes Cluster Services. EKS means Elastic Kubernetes Services, and GKE means Google Kubernetes Engine. So these are the service. That means basically in one click your clusters will be ready. Simple way. These are the paid services. I mean, see, software is free, but you have to pay for the compute, storage, and all things, right? Make sense?
Yeah.
Okay. So there are so many ways you can install the clusters. More than 40 methods are available. Okay. Now, now I'm going to show you the one demo for the one which is traditional manual and all. That's for learning purpose. For that you need to have a 2 VM at least, one master and worker. Okay, you can have a more masters also, because master is down then entire clusters will be down, right? So that way when you set up a production, minimum we set up with the three masters minimum production. And when you set up a worker machine, depends on our requirement how many containers you want to run. Okay, so there's one question which is not answered right now, pod. But before that, let me set up a clusters. So what I will do, let me log into AWS, and I need a VM actually. Okay, and you will start with this method only because learnings is important. Okay, and now I needed two VMs, so two large VMs. Okay, so here now my demo which I am showing you in Ubuntu 20x. Why? Because I have a script for it which has automated every process. But if you want to run in a different operating system, you have to modify the script or download from the instruction from the official website. So remember that script will not work for the other platform. So where is Ubuntu 20? So I have Ubuntu 20 somewhere in the recently I used actually. Please remember that my demo is around Ubuntu 20. Why? Because every operating system and then version of operating system, the commands will change. Okay, so this is 24.22, 24.22. This is the Munshid Ubuntu server, right? Here I'm using. Now I need a large machines because small will not work. So I'll go for large, 2 CPU, 8 GB RAM minimum. Okay, that's for the learning purpose. For the production, a lot of it. Okay, now I have keys and allow everything. That's not a problem for time being. And minimum I should go for 30 GB disk each machines, and I needed 2 machines, one for master, one for worker, and launch. Okay, so done. So let's try now. Two machines I created, or one? Two, right? Is there? Okay, so this I'll name it master. By the way, you should create the through Terraform, the one which I taught you yesterday. I created manually because just I wanted to show you how real things works. So here this is a master server, this is the worker server. So let me do that. So go log into this master server, putty, and here auth, credential, and ppk. Username is Ubuntu, and bold 14. Okay, apply. So is it visual screen, all of you?
Yes. So, how did you get that certificate? The .ppk file.
That you, when you create a EC2 instance, no VM, then that time you get it. I'm using
Mm.
only one all the time. It's a one-time activity. You can create one time and then allocate same, use reuse same again and again while creating.
Okay.
It's a key. So it's not certificate, it's a key. Okay.
Oh, yeah.
Okay, so this is the my master machines. Okay. So far so good. Any confusion, Patrick?
No, I'm good with this.
Madhu?
I'm good.
Okay. So what I was doing, yeah. So guys, this is Ubuntu 20. Again, I'm saying now I have a instruction code for it, entire code for it. So Kubernetes install DevOpsSchool. Okay. So this is the one. Now if you go for it, here you have a multiple method. So this for 20, 22 for this one. So this is also 20, Ubuntu 20. This is also 20. And this is also 20, by the way. Different methods are there. This is RHEL, old method. I mean, I'm not using that right now. I have not updated from last couple of years, actually 3-4 years. This is for 16. I remember like when, I mean, I think 4-5 years old documents. Okay, so I'm using this one. Okay, so this is one. Now all this code, you have plenty of codes actually. I don't want to run in front of you because it'll become a nightmare. So everything you have in this script. So this is script which is inside this repository. You have install master. This will do entire master's work. And same thing in the worker node. This you have to run in the master. Worker node you have to run this script. Now you may be curious what exactly that is. So again, shell scripting is like a basic one. Everyone must know that. So here if you go to the cluster setup and latest, I need to update this script actually, and install masters. Look at this here. These are the script. Now one thing is important in the master is init. Remember init. So where is this? Look at this. This will set up your master actually. Okay, and many other commands are there which is required for the clusters. Now if you go for the worker join, remember, uh, just a second. Join. This command will give you the join command which you have to run manually. From here we are not running. Okay, so that's good. So now what to do? So again, now you know. So let me run this, cloning this repo, getting inside this, and finally permissions for the script, and this will set up master. This will do everything, don't worry about that. So make sure that you have a right VM, right version of VM, and right resources like CPU and RAM and disk. Should be okay. So it'll take a couple of seconds and it'll be done. Okay, I want to tell you one more thing. This script which I'm running, this will set up a master for sure. All this thing, it will install all this utility, and this will configure this one also. But also qctl also will be configured. So I need to discuss this one how it works. But two things, it will set up your workstation also, by the way, because if you remember in the master you have a qctl. So for you to set up, there's some commands to run, which I'll show you that later. Done. Okay, so your cluster is configured now. See all the install certificates set up, all these things, you got it. Almost. I would suggest, if you have a very good laptop, keep your clusters always ready and keep doing something actually in the clusters. Have one machines in your home, uh, which should be good configuration, and you do everything in that machines. Okay, so it's a good practice, because this software engineering is our work, right? We have to keep it, our resources, very clear. Okay, so now it's configured. Now here, if you look at this is the message. Kubernetes control plane means master has initialized successfully. Now they're saying, hey, these are the commands to set up workstation. Now if you see that, this is the certificate access, basically I need it, and we are copying in the user locations and giving the permissions. So this is something which I need to understand, we need to understand. And this command, you see, I need to run in the worker, like command to add in a worker node. This is a join command, remember. So this has some token also generated at the master server. Everything is automated, so you're not doing anything as such. So this is done. Okay, now something similar I will do with the worker also. Ubuntu worker, I'll make it white. Okay, now sudo -s, that's, and now go to the installation document, same thing. You can make it one command also, but just to people to understand that every command is separate and you run like a lazy person. But you can combine into the one also, that's up to you. and this is a worker script. And finally, this don't copy. People, what they do, they copy this whole things blindly. But this command you should not copy from here. Why? Because the token and IP address for this API this is the API server address. API server, if you remember, what is that? Look at this API server. Everyone talk to API server. So this command you should not call it blindly. Please remember that. If you run blindly, nothing will happen because this is wrong, right? This is wrong. Token is wrong. It's a fake one. So where you should get it? So you should get it from here. Understood?
Yeah.
So let it happen. So I have bought one laptop with 64 GB RAM and and 2 TB disk. So I think probably it will deliver next week. So because what is happening is like for every demo I have to create a VM, right? Now I'm thinking I should create a VMs locally in the laptop with some automation and use it. So hopefully that machines, though the ranking was not good for that machines, but configuration was good. So I was assuming like even though if they can deliver the hardware, that should be okay. So let's see. Okay, so now you have run this. Now you should get this command and copy it very carefully and run in the worker. Done. So now what you have done is configure master and then worker. So worker configuration still need to be confirmed. Just wait for a few seconds more.
So one note I have, like right now you are setting up the worker node, right?
Yeah,
So you are inside the worker node itself. Now
yeah.
when you are executing, why do we need the API server API? Like as you mentioned, this API would be of the API server
Ha.
or of the.
So see, you need some sort of all communications clusters. So in real time, 3 nodes will be there and hundreds of worker will be there, hundreds of worker. So
Okay.
how they can combine together and communicate well to ultimate your ultimate goal is what? To run your containers at the large scale, right? For that, some mechanisms are needed, right? And for this software has been designed accordingly. So API server is for all the internal and external communications, and anything it receive it stored in the etcd. That's a persistent storage. And every of these component, if you see, have a different role. I just suggested scheduler will schedule the pod to the kubelet or worker. Controller manager will monitor the entire clusters and so on. API server will receive request and receive send request. Proxy for the networking services talk to APIs. So everyone need to communicate properly to work cluster function, right? like that. Okay, so now if I see that this is holding a time, so now I guess that's what is the problem. So here the port number is 6443. This is not open because I created this one just now. So security groups you have to modify. See, it's not allowed. So I am going to add, you should add the 6443, but right now I'm lazy, so I will delete everything. So what's practice, by the way, very, very worst practice, but I'm doing just to avoid any communication issues from anywhere, because the demo should be flawless. Okay, now see, I allowed everything and now it's cluster setup. So here you see this node has joined the cluster. That means every worker node can join the clusters. So now worker is set up and master is also set up here. So now we need to set up a workstation. So far so good, all of you?
Yes, sir.
Okay, so now how workstation works. Typically, I call it workstation because I've got habit of it, but typically you can call it a client. Okay, your the place from where you send the request, because most of the time workstation is your laptop. So I started calling workstation, but there's no official terminologies. kubectl is your client, simple. Okay. kubectl is your client, and this kubectl here which are running your master is your server, simple. So uh, workstation, so typically in your laptop you install the kubectl. kubectl need to know API server. Look at this here image, you will have a visualization. This one, I mean missing, see here, top. kubectl need to talk to API server. So how they will get the address? API server means that IP address, the one which I showed you, 6443, something like that. This is the one. It's a private IP address and port number. So how do we get it? So they read the one default file, though it can be many ways, but I'm not reinventing the new things. It's a default. So go to your user home, and there will be one directory cube, and then there's one file config. So basically kubectl read this file by default if it is available. Now how come it will be available? So if you noticed here, I showed you, look at it carefully, see here. So actually this file is created when you set up a master, and you reuse this file to configure the kubectl. They are giving you the instruction for it. So that is something which you have. In this file you have many entries, clusters you have, context you have, and user certificate you have. So all this information you have it. So I would suggest you to spend some time offline and understand this. But this file is very important. Let me show you that file. So what I have done in this master, I've set up a workstation also. This file I copied it through script only. So I want to show you. So ls see, and pretty long file, right? See, so you spend some time to understand the template of it, but there's one command which is simple, kubectl config view, which will read the file and give you in a simple way. Look at this. So they remove all the certificates and all. So now what is this? So look at this. This is a simple way to explain it. See, so you have a cluster section, and then context section, and then somewhere user section. Okay, and so here if you see cluster, you can be working on the multiple cluster, but right now only one. This is the API server, and this is the user. All the certificate data here you have. So we combine this clusters and users into the context, and we name it, the name of the context is this one, and you set this count. So that means by default when you send a command, it will send to this context, and this context means this API server with these permissions. Okay, so spare some time and you'll get it. So yeah, how the workstation works. So kubectl need to be there and this config file need to be there, which comes from the master. You can generate it also. There are so many ways actually, but right now no need to complicate. So workstation is done. Okay. So far so good. Any questions? Ashita, Madhu?
Good, sir. Thank you. I'm good.
Okay. So we have set up the entire cluster. You see, let's recap this to you. What is Kubernetes? So it's if you love containers, you want to run at the large scale, answer is Kubernetes. So typically that keyword we call it orchestration. So compute orchestration, storage orchestration, network orchestration, security orchestration, DNS orchestration, load balancer orchestration for what? Containers. So that's a Kubernetes. Okay, written in Go from the CNCF. Actually, it was donated to CNCF by Google and it's become open source. How it works? So you have a workstation, master node, worker node. Master node, you have a couple of softwares. Worker node, you have a software. Some utilities are there, some tools, every nodes of the clusters should be there. Masters and working together, we call it a Kubernetes clusters. How do we set up? I just showed you. Okay, many ways to set up. How the workstation works? So kubectl need to be there, and then config file need to be there. Config file has the clusters, context, and user. Now, because in my master machine, I already set up already did this, it will work. So my master machine is equal to my workstation also. That means I am running the command inside a cluster. In the real time, you won't do that, but for learning, you have to do that. So see, kubectl is a command to query everything to the clusters, kubectl. So you have to focus on learning the kubectl command. The more you get comfortable, the more you can send the instruction to API server from outside. So I query, hey, get me the nodes. Okay, here it is. Okay, now one thing I would like to tell you, I told you, right, for running the software, you need these many applications, right? But how it is running? So I want to show you, but before that, I want to talk about what is pod. So if you remember the pod, I said somewhere here, correct? Pods means container, something like that, correct? So what is the image of pod? Pod, human pod. See, this is the example for pod. And inside the pod, what we have? Inside the pod, you have a human. Okay, think simple, okay? So pod is a conceptual word. Okay, inside the pod, typically you have a human, and human who's a worker, who's doing the work. Work means compute unit. The people who's doing the work, real work. We are the worker, right? We are all are a worker doing some work. So assemble to the pod. Now, if you want to send this worker to somewhere, ship the pod itself. Are you understanding the concept? You don't have to ship this guy because human will be worker. Worker will be shipped along with the pod. Are you understanding?
Yes.
So it's a conceptually. So here, what is pod? So actually, pod is a conceptual word in Kubernetes. How? Let me tell you. So let's say if you go to the VMware, okay, what do you create? The VMware, when you go and use it, you create what? You create a VM, correct? Now, when you go to Docker, last session we had a Docker. When you want to, so VM is a compute unit, right? Correct, no, Patrick?
Yeah.
Hello?
Yes. Yeah.
Yeah. So when you go to the VMware or let's say AWS, what do you create? Every time you go to AWS Azure, right? Just now I created what? VMs. But when you go to the Docker, what you create? Container. Okay. So similar concept, when you come to Kubernetes, create a pod. Simple. Now you will say, what do you have in VMs? So in the VM, typically you have a kernel plus applications, means operating system plus application. Okay. In container, what you have? You have only applications, correct? No kernel. And in the pod, what you have? Containers, multiple containers. So here in the VMware, VMs or AWS VMs, you get IP address. Container Docker also get IP address. So here pod also get IP address from what? Kubeproxy. Remember here in Kubernetes, pod get IP address. That means if you have 4 containers in the same pod, same IP address can be used for all 4 containers. So what is a pod? Pod is a atomic unit of deployment in Kubernetes. That means when you say, when you are on Kubernetes, they never say containers. You say pod. Okay, you say pod. So pod is initialized by kubelet. That's the agent which is in each node actually. By and Docker container D is filling the containers into it. The containers into it. Now you know the Docker and container D well, correct now? So inside a pod, see, initialized by kubelet. But who's filling the container inside the pod? Docker and container D. Who's assigning the IP address? Kubeproxy. Kubeproxy is also in every nodes you have. See here. Kubeproxy here you have here also, and kubeproxy in the master also, worker also. So this is the pod. In short way, if you're in Kubernetes, if you want to run your application, you have to deploy the pod. Pod will have a containers. You may have a 1 containers, 2 containers, 10 containers. Pod get IP address. Who initialize the pod? Kubelet. Who's filling the containers? Docker and container D. Who's giving the IP address to this? Kubeproxy. Clear? What is pod? In a simple way.
So we can have multiple containers in a pod.
Yes, yes, you can have a multiple containers. Here right now in the image, you see pod have only one human, but actually you can have a multiple humans pod. Let me see if I can get some image. No, it's not coming. But pod is a conceptual word. Okay, see here this pod. This has a 4 human, right? Look at this. These are the worker. Containers are our worker. Real work is done by containers. But how do we deploy in Kubernetes? Pod.
Okay.
Make sense? Okay. So
So
now, guys,
and just to clarify, so basically we need all of these. First, we need to have a VM, I mean, or a physical server where we host the Docker and we create a container. Once the containers are there, like we can deploy it to like pod.
oh no, 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 no. But directly you can deploy.
Mhm.
No need to specify containers. Everything will be done
As a,
automatically. Everything. See, that's what I said. No, look at this here.
Mhm.
The moment, see here. Let me show you the image. That will be easier for you.
Okay, a blank pod also can be used. It can may or may not have a container, is it?
Yeah, yeah. Let me show you this. See here. This is a human. Okay.
Mhm.
Humans say, hey, give me the hey API server, give me 5 pod. So
Okay.
pod of what? Pod of Nginx or Apache, something like
Mm.
that. API server will store this in the etcd. Now etcd have, it's a fresh request, never came, so it's a fresh entry. Now
Mm.
API server controller will say, hey, this 5 Apache pod, you have 0, the status in the cluster, because they'll keep monitoring everything, right, in a different way. This is a multiple API server. Okay, multiple functionalities are there, multiple functionalities are there. Okay, so everyone is talking through this one only. So controller will report to API server, hey, there is a 0 pod. So then now the API server will request, okay, we need to deploy 5 pod, and so scheduler will pick this activity from the API server, and scheduler will request to the kubelet, hey kubelet, initialize the pod. So one pod you initialize, second pod, third pod, fourth pod, like that. Okay. Now kubelet will initialize the pod. Now kubelet will ask, hey Docker, fill the container inside this. Okay. So container
Okay.
has come. Now this guy only say proxy by default any compute unit will get a IP address. Proxy, this networking services. So now here you have container which has applications access
Mm.
through the pod IP address, and it's running, application is running. So
So
this
one
whole
thing I have, one question I have. So we need to create an image here.
image will be part of the Docker. Remember, in the Docker you run
Yeah.
containers, create image Docker file. So that image is ready. Image where you upload it, Docker hub, here it's a registry.
Okay, so
So
we
who
have.
will
Okay.
who
So
will
before that, no, one question, like if I need a specific image, so I have need to create that image through the Docker, and then I need to uh, put it into the
upload?
registry, Docker
Yeah, this
registry.
is
Yeah.
correct. This is you, this is your laptop, and you will create using Docker file or container, whatever which I covered last session, and you send this image to Docker Hub. Okay. Now Docker Hub container runtime is your Docker if, then automatically it will pull from here.
But we need to provide the address of that registry, correct? Image
So by
registry.
so registry by default the name itself automatically name itself when you let me explain it to you. When you say pod, so pod of what? Nginx. Nginx will image some image, so that you specify in the request itself, and that will be stored here. And that same request will be sent to kubelet. Same request will be sent to Docker. Docker will pull the same images what you specify here. So basically, whatever you requested, same image you will try to pull it.
Okay.
Got it? So this is how at a large scale you run this. This is the only one worker you have, but you may have a multiple workers also. Makes sense, all of you?
Yep.
Now one more magic of Kubernetes what you have. Let's say this guy requested, hey, I need a 5 pod. Okay. And just imagine there is a two worker, one more worker here it is. So scheduler deploy 3 pod here and 2 pod here. Okay. Or let's say 5 pod here only, or anything, no problem. So the moment, let's say this worker is down, so how much you had a desire, human has desire 5, controller report how many you have, 3. So there is a mismatch, right? 5 and 3. Then again scheduler will APSer will ask a scheduler schedule the 2 extra. So that will be done by Kubernetes automatically. You don't have to do that actually, automated way. So that means if anything missed out, automatically Kubernetes will match that. They have records here. So this is the only state persistent storage in the whole clusters.
So
Make
if
sense?
we need 5 pods, let's say, then there'll be 5 worker nodes. I mean, it will come,
Um,
every pod will
five.
come with the cube. Mm-hmm.
No, no, no.
No,
Why
there'll
we
be
need a
five
five?
pods within the. Okay.
It
So
can
in
be
what
depends on.
scenario we have multiple worker nodes?
So let's say you have a 5 GB RAM here. Okay, just example,
Okay.
5 GB
Mm,
RAM, and let's say you want to run 10. You want to run 100 containers. So what you will have? So the testing has happened. If there is a traffic, I need, let's say, 5 GB. You can run 10 containers only, 10 pod.
mm,
So how
okay.
many nodes you need? So you need in this case 100 total containers, 10
Mm,
containers in a 5 GB. That means 10 is to 10. 50 GB RAM you need, correct now?
mm,
So what you do? 50 GB RAM you need. So either you have one worker with the 50 GB, which is not a good design, because if this is
mhm,
down, entire thing is down. So typically what we have a more worker actually. So that way, when the one worker is down, second, third will be there. Correct?
Oh, makes sense. Yep. Understood.
Okay, so this is something which we have. So pod is a logical unit. Okay, container is a physical unit. If you say, I'll put it in this way. See, planet Earth. What is this? So planet Earth, you can touch it, you can experience it, right? But have you experienced the sky, empty sky? No, you cannot touch it. But planet Earth is inside the sky, something like that. Pod is a logical unit. You know it exists, but you cannot experience it. But containers you can experience because that's where your applications are running. You can go inside a container, you can see the logs of the container, you can start the container, you can stop the container, all these things. Make sense?
Yep.
Okay, so it's a logical unit. So in a nutshell, when you are in Kubernetes, you say you want to deploy a pod will have containers and so on. Simple. That means if you want to deploy applications, which is a containers, you deploy in the pod in Kubernetes. So that is something. Now you know what? We deploy our application in a pod. So these are also application, right? These are also application, correct? So this should be also in a pod, right? So do we have in the pod? Let's check it out. So there is a command qctl get pods. I'm querying it all all name spaces. Spelling mistake actually. See here. Look at this. Get pods from everywhere in the clusters. I'm querying the Kubernetes. Okay, Kubernetes. kubectl is a way to work with the Kubernetes. So here you see, look at this. Let me get this here. So here, if you see that, this is the API server. Look at this, it's running here. Controller is also running in the pod. You see here, Scheduler is also running in a pod. APS, etcd is, where is etcd? Here it is. etc is running also in the pod. Okay. Now, why we have a two proxy? Because two worker is there, remember? One master, sorry, two node is there, right? One master, one worker. So every node will have one proxy. These are networking services. Now, this is discovery services. I mean, it's not a core component, but actually nowadays it's a core component. So this will manage your DNS, all the records and all. And this is your software for um, kubeproxy. So kubeproxy, all the plugins software for it. So Calico is a basically plugins. Okay, software. You network driver, you can call it simple way if you want. Okay, so this is the network plugins, network driver. This is your networking. So everything is running in the pod itself, you see. So in this pod, you have what? Container. Container come from what? Image. Image come from what? So these images, typically the image is from the hub.docker.com, right? So, but these image you see Google registry. Google also has a registry and you can share your image actually. So there's so many registry. AWS, we have a ECR registry. Google has a Google registry like that. Hub is a popular public one for the Docker. You can create your own registry also where you can host your own images also. So these images, what you see here, these images come from the Google registry. Make sense? All of you?
Yes, sir.
Okay. Okay, so now what is your work actually? So now after knowing everything, your work is only learning kubectl, that's all. And API resources, I'll tell you. See here, all these commands, basic commands, intermediate command, deploy command, cluster management, if you're admin, troubleshooting commands, some advanced commands. So these are your work to learn actually. And what you want to do with Kubernetes, because this you will learn, but why? Because you want to deploy something on Kubernetes. But you will say what I want to deploy. So only I taught you only one thing, pod. There are many resources. How do I know? There is one command, kubectl API resources. You have to deploy everything. Look at this. This is your real learnings. This is your real learnings. Focus on it. Spend some time, half an hour, 1 hour. Start recording your documents. I only talk about the pods. Here it is. See here. But there's so many components we need to learn. These are the things you deploy in the Kubernetes. For example, I'll give you a simple example. When you have a little bit of idea on the cloud, so what you do? Typically, EC2 you deploy. Then for storage, EBS you have, S3 you have, EFS you have, correct? For networking, you VPC you have, correct? For security, maybe KMS you have, correct? Maybe IM you have. What else you have? Load balancer you created. Route 53 for DNS services. These are the on AWS you do that, right? Similar services we have on the Kubernetes, Azure also. So something similar, because I said, remember, Kubernetes for the running production. So a lot of services you have, resources we call it, and most of these resources we need to learn actually. I mean, top 10 if you learn, that is covering the 90% of the scenarios, but all of around 50 resources you need to learn. Like a pod is one resources. Okay, node is another one.
So these resources are also logical or they exist in real life?
Okay, so these resources is basically feature for Kubernetes, just like a pod. Pod is a feature, right? Correct. Pod is like a which will run containers. But now see, I'll give you an example. You deploy the pod. How many pods you deploy? 10 pod. But you need a load balancer, right? What you will do? So then if you need a load balancer for pod, what you do? Example, you need service. Service is equal to load balancer. Likewise. Got it?
So first we need to know what are these resources and what is their
Correct.
function.
Your job is to know this one. Just I just explain you what is VM, but rest of the features also you need to know. Correct. So similar things, something similar features we have on Kubernetes also. Okay, so this is something which you have. You see, look at this here. These are the feature resources we call it, and then short name also there. API version is there. What is namespace, true, false? We need to discuss and stuff like that. So yeah, this is work. Which Kubernetes version you are using? Look at this command. You just practice it. See here, 1.29. Latest is 1.3x actually. So I think we are 6 months behind. That's okay. It's the same features almost. What else? So many commands are there. You practice it. Some of the commands. Let's say cluster info. Where is your API server and all DNS? So here you have. Look at this. This is your API server 6443 and your DNS discovery service is running at this. Okay. So now everything you hit from the command line. I mean outside of the cluster, something like this, and you talk to API server, and masters will do everything for you. Make sense?
And to set all these resources, we can use the Terraform like yesterday you mentioned.
To set up a master node and cluster node, you can use a Terraform. I set up manually, but typically we should use Terraform. But I just
And
said no.
we can
If you
use
are,
Terraform and okay. I mean,
I
we
just
can
said no.
use our VM environment also, right? To
I taught. I mean, I showed you manual. Remember, we don't do in the
mm,
production. We manual. But when you go to the production, no, we have a AWS EKS service, which will do everything automated way. But for this, we need a Terraform. Correct. So what to do?
mm.
I told you. Remember, every module has been developed. This is the module which will set up a EKS in your AWS. This is the module. How to use it? Here it is. So this will set up your whole clusters and networking also. Three masters this code will set up, and worker depends on your requirement. Got it?
Okay. So, to practice, like, what do you suggest? Like, we should use
The one
AWS, or is that like
No,
to use our local? Mm-hmm.
AWS will be costly because it will set up a production grade clusters. No, 3 node, multiple worker will become costly. So the one which I showed you, you should practice same thing. Once you become comfortable, then think about the bigger one. Okay.
I mean, my question was a bit of like whether we should set it up to in our local VM or we should use AWS.
That way you can see. It's up to you.
Mm-hmm.
If you have an infrastructure in your laptop, let's say 8 GB RAM and
Mm.
some good CPU you have, disk you have, so you go ahead with that because 1 to 20 VMs you needed to replicate my environment. Now you can have that VM in your laptop and set it up, or you have in the AWS. It's up to same thing now. Ultimately, AWS will give you the VM, or your VMware also give you the VM in your laptop. Same thing, right?
Okay. Okay.
Only the
Sure.
version match if you want
Mm.
my script to work.
Yeah.
Okay,
Correct.
so now I think too many things. So what I want, you have 1 week of time. I want you to set up a clusters, and whatever I did, become comfortable, because once you become comfortable, my demo will be very simple. Okay.
I have one question.
Hmm.
So, like, master node one is enough, correct? Worker node
For
we can
learning,
define.
that's what I was saying. For the production, you don't need one more than one master, one worker. For learning purpose. For the
No,
production, you need a multiple master, multiple worker. No. For learning purpose, you can go for this one, the one which I showed you. This is not for the production I taught you. This is for learning only.
multiples. Okay, what is the
So,
benefit of multiples master? Worker, I can understand multiples, but what?
Okay, so see that in the image itself, if you look at this, think about it in the simple scenario. Master has some software which manage every worker, and the worker which is having running pod and your container. Basically, your application is running the worker, but who's controlling it? Master. Who's
Yeah, I
monitoring it?
got it.
Master.
So you mean
So
like
if
for one master node, there should be always one worker we have to define. Can we define
Mhm.
like two worker nodes
I
for
never,
one master?
okay, you misunderstood thing. I never said you need to define one worker, one master. I never said. Did I said?
No.
yeah, multiple worker for one
I
master.
always said this is the developer. Now you have one master and one worker. This is the master and worker. This is for this is the whole thing is called cluster. This is for learning purpose. But in the real, what will happen? You are running a production. Just imagine you are running production and you are running, let's say, 3 worker. Just imagine 3 worker. That's good. You are running all these 3 worker, and your end traffic, the end user is hitting directly to worker through the load balancer. But let's say this is down. What will happen? Your entire production is down, correct?
Yeah, got it. Yeah.
So what you need? You need again multiple masters, again few load balancers. So you send the request here, it will go here if it is down. So this whole 3 masters will manage your entire large clusters. So that means even though one master is down, second will be there to give the instruction. Remember which instruction? I explained you all this thing.
Yeah, got it.
So for learning purpose, one master. But when you go for production, you don't have to do that automatically. EKS, when you set up, let's say for the production, they'll set up a 3 masters automatically. They'll charge you for it. You cannot say EKS I'll set up with one master. They will minimum 3 masters.
Okay.
Just like
And if
Azure.
we have different environment, right? We have dev, QA, perf. So for that, also like we can have different masters. Like we can use one cluster where we can have different masters and accordingly the workers.
Yeah. Typically, we go for 3. Sometime 5. I have never seen 5, but many it can be configured 5, 7. This is and this. But yeah, QA environment and see in your learning environment, one master, one worker is sufficient. Uh, for QA environment, you will configure a little bit. Let's say one master, 3 worker, or something like that. So like that depends on the requirement actually. Okay, so this is something which I want you to get comfortable because it's a new technology, trust me. So I know that you are struggling with it because hearing is okay, but until you do that, you won't realize it. So struggle for few hours, maybe whole day, set up your masters, uh, run any commands. All this qctl is the only command you need to run and explore it. Okay. Explore it. So next session when I deploy the resources, nothing, each resources, these are the same, which I showed you. These resources. I'll deploy pods, I deploy deployments, replica set, replication controllers, services, config maps, secrets, roles, role binding, all this thing. I'll do that. So you will not be unknown. Okay. But yeah, let me tell you, if you're not practicing it, then definitely the next session will be going on top of you. Okay, any questions?